Suppose the following experiment is performed. An object of mass 0.25 kilogram is slid on a frictionless surface into a dark room where it strikes an initially stationary object of mass 0.4 kilogram. The 0.25 kilogram object emerges from the room at an angle of 45 degrees with its incoming direction. The speed of the 0.25 kilogram object is originally 2 meters per second and is 1.5 meters after the collision. Calculate the magnitude and direction of the velocity of the 0.4 kilogram object after the collision. So here, two masses collide with each other, and then we have to find out the final momentum or final velocity of the second object. Okay, so this is the collision, means we don't know whether it is the elastic collision or inelastic collision. Whether the collision is elastic or inelastic, momentum is conserved. So based on the principle of conservation of momentum, we have to solve this problem. Okay, so according to the data, mass of the first object is 0.25 kilograms, and it is moving with a velocity of 2 meters per second along the positive x direction. And mass of the second object is 0.4 kilograms, and it is at rest. Okay. After the collision, the first object moves with a velocity of 1.5 meters per second, making an angle 45 degrees with its incoming direction. That means it is moving along the positive x direction as per the given data, and then it is making 45 degrees with the horizontal. Okay. We are supposed to find out the final velocity of the second object and also the direction. So this is the data. And then, as I told you, momentum is conserved. Here, the first object is making an angle 45 degrees with the horizontal. So we have to resolve the velocity into components. Because it is making an angle with the horizontal, it has both the x component velocity and y component velocity. So when we resolve this into components, the x component will be the cos, because it is the adjacent side. The x direction is adjacent to the angle. That is why it will become the cos 45, 1.5 cos 45. And then the y component velocity will be the other one, because the y component velocity is opposite to the angle. That is why it is 1.5 sin 45 degrees. Now we will write the momentum. Momentum before, according to the principle of conservation of law of conservation of principle of conservation of momentum, momentum before collision is equal to momentum after collision. So we will take the x component momentum before collision is equal to x component momentum after collision. Similarly, we will equate the y component momentum. Y component momentum before collision is equal to y component momentum after collision. Just plug in the values, you will get V2 cos theta 2 is equal to 0.5870. Here I did the calculations and then I plugged in the values. This is the value I get. And then I equate the y component momentum also. Initially, there is no y component momentum. Okay. Therefore, it will be 0. And then after the collision, we are writing 0.25 into 1.5 sin 45 plus 0.4 into V2f sin theta 2, because we don't know the velocity and the direction of the second mass. So we will leave it like that. And then we solve for V2 sin theta 2 and we get this value. Now we know we have to find out that theta. So tan theta is equal to y by x. So this is the value. Theta is equal to tan inverse. This one gives an angle of negative 48.47 degrees. The negative sign indicates that the object is moving below the horizontal. Okay. So using this value, I will try to find out the velocity of the second mass after the collision. So for that, I will take this equation. V2f cos theta 2 is equal to 0.5870. And then I plug in the values. I will get V2f is equal to 0.8854 meters per second as the velocity of the second mass after the collision. Okay. So here simply I made a calculation equating the momentum. Momentum before collision is equal to momentum after collision based on the law of conservation of moment. That's it. Okay. Hope this helps. Thank you. Bye bye.